When adding and subtracting rational expressions, you need to have common denominators. So here in our first example, both of our denominators are exactly the same. So the first thing that we can do is combine this into one giant fraction. So when I subtract, just like when we subtracted our polynomials, we have to distribute that subtraction sign to the whole numerator of the second fraction. So I'm going to have my 3a plus 4, and then I'm going to have a minus 2a minus 2. So that's now my new numerator for my whole fraction. And in my denominator, I'm going to have the a squared plus 4a plus 4. But instead of writing that expression, I want to factor that using the British method or the box method. So I'm going to end up with a plus 2 and a plus 2. If it would have been something other than a trinomial, I would try and simplify it if possible. If it doesn't simplify, then I would just leave it alone. Now I'm going to combine my like terms in my numerator, so my 3a and my negative 2a to give me a positive a, and my positive 4 and my negative 2 to give me a positive 2. My denominator stays the same with the a plus 2 and the a plus 2. Now looking at that fraction, I can cancel out anything that they have in common in the numerator and the denominator. So they share one a plus 2. So that cancels out my entire numerator, but it still leaves me with a 1. And I'm going to have 1a plus 2 in the denominator. So I still also need to define what would make my denominator undefined, and it's going to go back to the original denominator of a plus 2 and a plus 2. So I would have to set them equal to 0 to figure out what that value would be. Since it is the same factor for both, I'm just going to write a plus 2 once equal to 0 and solve. So I get a equals negative 2. So my final answer will be 1 over a plus 2 when a cannot equal negative 2.